Hello engineers and welcome back to Civil Nirman. See, once you final your structure design, the main pain area is to prepare the structural design input so that your designer or draftsman can prepare the structural drawings based on given input by you. Now few of you might ask that, sir, what is design input? So basically it's an input from your STAAD file, or it can be a hand sketch which shows all the member sizes in framing plan for the RCC, and in case of steel structure it will represent the different section properties like main beam, secondary beam, anchor bolt, base plate, purlin size, bracing, etc. with respect to all the dimensions and levels. Now see, it takes a lot of time to prepare such input, right? So for that, usually what we do, either you provide a hand sketch or you provide snap from the STAAD section property manually. And as a structural engineer, we know that how painful it can be to prepare the design input for the framing drawings. And it's a tedious process that involves manually extracting member sizes, properties and dimensions from our STAAD files or the hand sketches. But what if I tell you that there is a faster way? So that's where Steel Autodrafter is a game-changing tool that allows you to generate design input quickly and easily. With just few clicks, you can extract all the necessary information from your STAAD file, including member sizes, properties, dimensions, and even material takeoff. So let's take a quick look how you can utilize Steel Autodrafter to change your game and make input precisely with less time. Now see, one important point to keep in mind that your STAAD file should be same as the architectural levels. Let's say if you have a model, your depth of foundation and the finished ground level, the plinth beam levels means the finished ground level, first floor level and second floor level in case of the RCC, that should be matched with your STAAD model, right? Then and only then you will able to extract the correct elevation. Let's say if we talk about the steel structure, your base plate level at the support locations and the elevations that are in the architectural drawing, that should be matched in your STAAD file. So that's the mandatory requirement that you need to keep in mind, so that drawing will extract the same elevations based on the architectural input the way you have prepared in your STAAD file. So here are the key points that I'm gonna discuss in this session. Stay tuned till the end and don't skip any part to understand it properly. Let's take a look.
So let's understand how you can create a basic input for your designer or draftsman in order to prepare the structural drawings. Now see, every consultancy has a different practice for preparing drawings, and they have certain standards based on their consulting practice since they are performing from many years. So it may vary from consultancy to consultancy, but if you want ready-made instant drawings, then Steel Autodrafter is one of the tools you can utilize quickly in order to prepare drawings. Now it can be used to prepare the drawings, as well as you can prepare a quick input for your designer or drafter in order to give them certain inputs to create your drawings based on your consulting practice. Okay, so basically the Steel Autodrafter extracts the planar drawings and material takeoff from a prepared steel model in the STAAD Pro. Right now, to do that, first of all, your STAAD file should be run. Means after performing analysis, you can switch to the Steel Autodrafter mode if you have this particular license to operate this. Right. So in the first phase, we will understand preparing the model in the STAAD Pro and how we can enter in the Steel Autodrafter. Okay. So first of all, you need to run your STAAD file. Okay, so I'll quickly run my STAAD file over here. Now once you perform the analysis, right, then you can switch to the Steel Autodrafter. Now if you haven't perform the analysis, means when you are opening your STAAD file for the first time, and if you directly switch to the Steel Autodrafter, it will give you a warning that you need to first run the analysis, right? So I'll now click on the Steel Autodrafter. So once you click on the Steel Autodrafter, it will change your STAAD files interface something like this. So basically it is configuring your STAAD model, and based on the section properties and profile that you have given, it will create a 3D model in the Steel Autodrafter itself. Now let's understand the different categories. So first of all, we will go to the property tab, and I'll just brief you about the different segments that are utilized over here. Now just to give you an idea what category of the profiles I have utilized, I'll just switch to the properties tab over here. Now you can observe we have different category of the segments over here with the different steel and RCC segment. Let me just show you a 3D over here just to give you an idea. So you can check out this 3D, right? So see, in the section database, basically it can be used to assign the section properties to the members in the model. As you are aware, if you have the basic knowledge of the STAAD, and the section names will be available on the plan and section drawings in the steel Autodrafter. So whatever the names are appearing over here, that will be reflected in your steel Autodrafter. Similarly, we can have the prismatic section. Basically, the prismatic section can be used to assign section properties to the members in the model, and that particular section name will be also available on the plan and section drawings in the drafter. Similarly, we can have the user table option as well. Okay, so it can be also utilized to assign the segments, right? So if I talk about the any particular sample, let's say this one is the angle star that is the specified over here. Let me just give you a quick highlight. Okay, so basically it's a angle star segment that is model using the UPT user provided table. Then I have another segment model which is this one. So you are aware about the prismatic and the general section part as well, but just to give you an idea. Okay, and then we can have the built up section or two ISMBs together, right? So this is one of the segment where I have modeled it as an the composite section. So just to summarize that, let me just show you what category of the model I have utilized in this particular STAAD model to give you a brief. So I have one angle star, then the built up section, channel section, and this composite section as well. Okay, and I have specified each definition over here. What does it specified in STAAD? So DPT represents the total depth of the section, WD total width of the section, WT represents the web thickness. Over here, see, whatever the synonyms whatever the short names which are provided in the user table property, that is highlighted over here. That's it. So I have created those sections with this particular name, FT flange thickness, and 10 inch that specified in this angle star represents the clear gap between two angles. About this, the 10 written at the end. Similarly, 100 represents the clear gap between the two sections. So that's what the property category I have provided. You can provide the names like these as well in your STAAD model. Everyone has a different practice, right? Now let's switch to the STAAD model first. All right. So first of all, what we will go that we will switch to again steel Autodrafter model. So once I switch to the steel Autodrafter tab, here we have, you can observe, we have different categories of the tab available over here. See, so this is the steel Autodrafter ribbon, and here you have various different categories of tool grids, drawing groups, drawing style manager, node numbers, member numbers, grids, view drawing list, drawing and text option over here, right? We will understand the basics, we will not go into deep, but it is just to give you a quick idea how you can utilize this tool in order to prepare a certain input for your designer or the draftsman, or if you wish to provide a quick drawings to certain clients for the reference part, you can generate it from here, right? So let's understand this steel Autodrafter workflow. So first of all, we will go with the drawing style manager. So basically the drawing style manager is used to customize the drawing styles to facilitate the production of drawings, and let's understand how it will work. So I have clicked over here, and once I click on the drawing style manager, you can observe we have a tab over here. I'll click again. So here you have different segments: layers, member labels, and appearance. Okay, so layer tab basically used to change the layer name and the color for each type of object that is utilized in the Steel Autodrafter. You can observe over here the grid has certain color, dimension has certain color, label or steel beam, RCC segment or bolt has certain color category. So you can change it if you wish to from here. Similarly, member labels, if I click on member labels, they are used to customize the description of each member that will be displayed in the drawing. Okay, so if you wish to change anything, you can change it from here. Currently I am not changing anything, this is just to give you an idea. Alright, similarly in the appearance tab, it is used to specify the font data and the dimension style. So it is related to the representation part. Let's say if you want to switch your drawing into the metric unit part, it will easily convert that into metric unit. If you want to keep it in English, you can do that. The label, text height, text size, arrow size, dimension, and the basic graphical representation part is available over here. So if you wish to change this unit part, you can change it from here, right? So this is basic information on the drawing style manager. Now I'll click to the grid option over here. So once I click on the grids, you can observe that based on the STAAD geometry that you have prepared, right? Along the X direction, along the Z direction, whatever the number of bays we have, whatever the number of columns we have along the X direction and along the Z direction, based on that it will automatically generate your location and the grid marks over here. Let's say if you want to create a separate grid in between portion, you can create that too. Okay, just to give you an highlight, let's say in this two bays, let me just switch it here. From here you can switch your model to, right? Now if I just give you an example, let's say currently we have, let's say grid 1, grid 2, and you can observe that if you want to create the intermediate grid for this particular reference members, then you can do that too as well. Okay, just for your information. So every grid has been prepared over here. You just need to identify the location and you can enter the grid numbers. Currently Autodrafter has given based on the main grid location, but you can see based on the distance part, it has that subgrid locations as well, and you can rename this as well. Alright, so you can observe that at the 0 location it is A at 16 feet, it is B. Similarly, if I go further, it has created all the basic grid plans. And similarly in the elevation portion as well, you can mark each elevation. Okay, let's say you want to start from the 0 part and you write something here, let's say ground level GL, then first floor, second floor, third floor, likewise. So this particular segment will be represented in your drawing as well. So just for your reference, I'll just give a short name over here as ground level. Okay, or I can give it as finished ground level FGL, just to give you an understanding, because see in the elevation part it can be used to identify all the levels. Apart from that, by default it will identify, but just to give you a highlight, I'll just put it over here. Okay, so it has prepared the grid part. So once I update this and if I click over here, you can observe that the grids are created. You can see that A, B, C, D, E and 1, 2, 3, right? So that's how it is created. So I can modify this based on my requirement, right? So this is just a quick overview for your information how Autodraft works, okay? But we need to understand how quickly you can prepare the drawing. But as this was the first session, I try to cover all the basic fundamentals that you need to know about the steel Autodrafter part. Okay, now next important point is you can create grip over here as well. Okay, so let's say I'll switch to the another portion regarding the groups part that is available over here. Now you can create groups as well. So in order to create a group, so for creating group you just need to click on the drawing groups over here. So once you click over here, Autodrafter will automatically identify the location, see portal, top chord, bottom chord, bracing and incline column, right? Now let's say I want to create a group on the portal, so I'll click on the portal over here. I'll select the member first. Let's say for this particular member we will select one particular group, okay, and I'll click on the portal option. Sorry, I'll click on the member, then I'll click on the cut section along X. This is along X. Now you can see it has identified the groups, top chord, bottom chord, portal segment, likewise different scenario, right? So what I'll do, I'll just quickly click over here. So this is my portal segment and I'll just select. You can drag and select the elements like this, or you can manually click, left click and select the segment. Now once you do that, right click, create group. See, this is the horizontal spacing between that particular segment, so it is highlighting over here. Now I'll click on OK. So you can observe the first group is created for the portal segment, right? Similarly, you can choose the second option. Let's say for the next grid, you need to go further, draw section, cut section at X. Then again I'll select the portal option, right, and I'll select all the grids, create group, right? So in portal we have these two options and you can see over here the group is selected. This is first one, this is second one. So similarly you can select the entire frame and make it as a portal. I have just shown you a sample reference over here how you can create. You can select the entire segment and make it a particular group the way we do in STAAD for the entire frame. Similarly you can create group for the top chord, bottom chord, bracing and inclined column, right? Now let's understand the main portion that is most important, that creating the plan and section drawings, right? So let's first understand how you can create a particular plan. So I'll close this, I'll make it arrange again in the normal mode. Now let's understand how you can create the plan. So for that, in the main window I'll click on one of the member. Let's say at the ground floor we have, at the plinth level we have one of the RCC beam. I'll click over here, I'll click on draw plan at Y. Y means this is indicating your level. At this particular level you want to draw the plan, or you want to cut the section or draw a particular section. All options are available. I'll choose draw plan. So once I click over here, it will give me this particular option and I can click it to add to drawing list, or I can simply click on the draw option. So once I click on the draw option, you can see that it has created a direct AutoCAD format drawing for you with the section profile and size. So this is what I am talking about. It will be very helpful for you to give this particular input to your designer or a draftsman who is preparing your structural drawings for the steel or the RCC member, right? Every grid with dimension, with label, it has specified. Now why I was saying, because see, every consultancy or industrial company have their own practice, and based on that they provide names and labels. But in order to generate the quick drawings, or in order to prepare a quick input as a structural engineer, this will be very helpful to you. See, B1 is identified over here as the section size, whatever you have provided in STAAD with the section profile and name, it has automatically created. So it will be a lot of time saving for you, right? So this is the section profile that it has generated at the ground level. Okay, I have provided that particular name as FGL. So see, it has provided that name as FGL. Similarly, you can mark your elevation as ground floor, first floor, likewise, or in case of steel structure, you can provide top of steel elevation or anything. Means elevation, floor plan at this level, floor plan at that level, or the top of steel level. It will be helpful to you. Now this you can simply take a printout or create a snapshot, take it in Word file, or export and take out a print and provide it to your designer. So it will be a lot of time saving activity. Now see, one important thing over here that I want to make sure that, see, this particular drawings can be viewed on screen or saved as a Dxf file. But however, if you want the drawings to be available the next time when you enter the steel Autodrafter mode, you must add the drawings to the drawing list. So if you don't add this in the drawing list, it will be not available, right? So let's understand this, how you can do it. So I'll go to the layout option. Okay, I'll go again on the member, and here draw at plan, you have this another option called add to drawing list, right? So here when you click, it will create a drawing list whatever the segment you want. So I have created one drawing list at this particular plan location, and manually you can add further whatever the plans you want. Let's say at this level, whatever the level. I just give you a sample highlight over here. So that's how you can add it. This similarly, let's say I want another drawing plan at this level. So if I click on draw, it will directly draw, or otherwise I can click over here, it will add it to your drawing list. Now once you add this on your drawing list over here, you have several options available: plan, section, plan projection, all the grids if you want a specific grid, full section, part section, and the scale portion. And here is the option from where you can take out all your drawings directly from this drawing option. So currently I am not exporting everything, I am just preparing a list over here. Similarly, I'll choose the another option over here, draw plan at 6 meter. I'll click on this, add to drawing list. Right now, once I click over here, click on the draw option. See, it will quickly prepare all your drawings. Right, see, at drawing 1 we have written FGL, so it is shown over here. At 2 I haven't written anything, so it is just simply representing TOS. But if you have marked your elevations at the earlier stage, it will give you everything with the plan dimensions and the section profiles markup over here. So it is marked over here, and each segment, let's say GS 1002, so it is marked as GS 1002 with the section profile. So this quick input is ready made for your designer or the draftsman, so that he can quickly prepare your drawings based on this, right? So it is very helpful to create all this. Now let's understand how you can create a section part. So I'll go to the layout mode option again. Now similarly, I'll click over here in one of the member, and I'll select this particular section and want that I can cut a section or I can draw a section. Both the things I can do. So similarly, you can draw a section at particular location, you can add it to the list, right? If you want this section on the Z, similarly you can add for all the grids 1, 2, 3 along the length, along the width, add it to the list. Now let's say if you want all the sections, then what you can do is just click over here, right? Select section for all grids, then click on add to drawing list. It will quickly add. Similarly, I can add section from Z. Click on the drawing list, it will add section from all the grids, right? And I can just simply go for with a single click over here. You can clear the list from here. If you wish to delete anything, you can just right click and delete too. Now I'll click on draw option over here. it will take little time as we have added so many segments. See, all the elevation and sections are prepared. So this will be very helpful for you to prepare the engineering. This can be prepared as an engineering input if you wish to show your clients, if you want to give some designer as an input. Everything is written over here with the labels and member size, so less chances of errors, and they have given with the symbol and description for each segment what each parameter represents, right? C steel column, GM girder, column to column beam with moment connection, shear connection, everything in detail, right? Now for further, what you can do, you can click over here and save this particular as a DXF file format at certain locations, and DXF can be opened anywhere, right? So that's how you can create plan and elevation for your quick reference to provide as an input. Now the next most important task that you need to know is projected plans. Now see, projected plans can be used to draw plans that exist on a sloping plane. So currently I am talking about this sloping region. See, for rest of the elevations you just simply can create your plans from this particular location, but for the elevation portion there is a separate specification called plan projection. Now in order to work out this, you must have to identify the node numbers as well. Okay, so by simply going right click, you can identify the show node numbers option and you can identify the node numbers. So let's check out how it will work. So for that, I'll go in the option tab over here. I have the option called plan projection. Now see, for this particular slope region, I identify all four corners, 1, 2, 3, 4, and the top notch sloping region, right? So I'll enter the number of planes as 2, and I need to enter those node numbers over here, right? So just for your understanding, I'll just quickly show you over here. See, these are the nodes that I have identified: 31, 41, node 1, node 2, similarly node 1, node 2, and this isolated node on the reach area, node 67. So let's enter that values here quickly. Alright, so I'll enter here. Now once you click over here, you can drag and it will show you all the nodes which are associated with your STAAD model, or you can just simply enter the value directly over here, and you can observe that this point is highlighted over here. So I'll add 31, 41. Now for the better understanding, you can click over here, 67. I'll keep this common. Then this one is 35 and the other corner is 45, right? That is highlighted. So you can observe that this area will be projected in this particular segment. Now I'll click to the add to drawing list option. Now just to give you a clarity, I'll remove all those area first. Okay, I'll clear this section and I'll just add the latest one over here that we have created. Okay, and then I'll click on the draw option. Now you can observe that it has created this projected plan for this particular area, right? Rest of the fundamental is same, but this elevated portion is included over here. Similarly, if you wish to go with the other separate option, we'll switch to the layout portion again, and I'll show you another layout. Let's say for this region, for this particular region, I'll turn off first. What I want to convey is, let's say the upper region of this shelter. You can observe here this upper region. Okay, 1, 2, 3, 4. This upper region of the shelter, let's plan it for this. Okay, so again I'll give you another example to create plan projection. I'll enter 2 value over here. Now I'll enter the node numbers in order to identify. I'll turn on the node numbers. So here it is 69, then 172. Let me just give you a quick switch so that you can identify two. Okay, 69 172. So I'll enter 69 172. You can observe that that portion is highlighted over here. Then the middle one is 174 174, and the last one is 70 and 173. Simultaneously you can check over here, these points are highlighted, right? I'll click here to add this to the drawing list. Then again I'll click on the draw option. Now you can see that specific region is projected over here. So you can create this projected plan separately for that sloping region, right? So this is one of the beneficial portion for this elevated projected area as well. And last but not the least, we have this material takeoff. So you have the option called material takeoff over here. Okay, so by clicking on the text button over here, you can get that value. Once I click on the text option, you will get the material takeoff statement. Same segment will be visible to you here in the generated form. So this is the takeoff operation for all your structural member that you have used. If you click on the drawing option as well, that particular segment will be available here too, your material section list. Similarly, if you want the quantity portion, so once you are in the steel Autodrafter model, you can click on the drawing option over here. So the same quantity will be available in the table format over here as well. So that is all about the steel Autodrafter. As a structural engineer, if you know all these commands, it will be a lot more easier for you to create the quick reference drawings for your clients, if you want to show someone, or if you want to provide an input to your designer or draftsman.
So I hope you like this tool and the technique that we can utilize to prepare our structural engineer input to give it to the draftsman or designer, and it will save you a lot of time and checking as well, because as it will be based on your STAAD model. I hope you like this session. Similarly, I am sharing all my daily learnings and structural design fundamentals on our YouTube membership program, so you can join us. Link is given in the description box. Also, we are sharing the daily design tips on LinkedIn and Instagram. You can follow us there. That is a new course that we have developed for the designers and draftsmen for the Tekla content. Also, we have developed steel structural detailing course. That link is also given in the description box. Do check out that. Remember, don't just learn software, learn concepts. Thank you.